Ever stop to think about how your phone sorts all your contacts just instantly? Or how your social media feed seems to know exactly what you want to see next? Well, there's this invisible order to our digital lives, a set of instructions running behind everything. So the question is, how does it all actually work?
Well, the answer comes down to one single powerful word: algorithm. It's really at the heart of everything. It's the engine that takes a mess and turns it into something orderly, and that's exactly what we're going to break down today.
So let's get right down to it. What in the world is an algorithm?
At its core, it's actually way simpler than you might think. An algorithm is just a set of rules, a sequence of steps to solve a problem. The best way to think about it is like a recipe, right? The ingredients, that's your input. The instructions for cooking, that's the process. That's the algorithm itself. And the final delicious meal, that's your output. It's just the instruction manual for getting from point A to point B.
And this visualizes that exact same idea, just maybe in a slightly more technical way. You have an input, which we're calling x, that goes into a function f. Think of f as our little black box, the set of instructions. It does its thing, and boom, out comes the result, f of x. It's a perfect little diagram of that transformation from a problem to a solution.
Now, to make all of this feel a little less abstract, we're going to focus on one of the most common, most fundamental problems in all of computer science: sorting. Let's start with our input. Here it is, a sequence of numbers completely out of order. 31, 41, 59, you get the idea. It's just a jumbled mess. So the challenge for the computer is, how does it take this specific problem
And turn it into this, a perfectly ordered, sorted list. That how part, well, that's the algorithm. And just like we said with recipes, there's more than one way to bake this particular cake.
So let's check out a couple of these different recipes in action and see how they tackle the exact same problem with totally different strategies.
Okay, this slide shows a few ways to do it, but let's just focus on two. First up, on the left, you've got something called bubble sort. It's pretty simple. It just goes through the list over and over, comparing two numbers right next to each other and swapping them if they're in the wrong order. It just keeps doing that until everything is sorted. Easy enough to understand, right? But then on the right, you have merge sort, which is way more clever. It uses what's called a divide and conquer strategy. It splits the list in half and then splits those halves again and keeps going until it's got a bunch of tiny lists with only one number in them. Then it starts merging them all back together, but in the correct order as it goes. See? Two very different ways to get to the same finish line.
Okay, so we have two different methods that get us the exact same result. That brings up a really important question. Is one of them actually better than the other? And this gets us to a huge idea in computing: the efficiency race.
So which one is it? Which algorithm wins? The simple, straightforward bubble sort or the clever merge sort? And for that matter, how do we even measure what winning really means here?
And this table just lays it all out for us. It compares how different algorithms perform as the list of numbers gets bigger and bigger. So look at bubble sort. As the job gets larger, its performance just tanks. It gets dramatically slower. But merge sort, it stays incredibly efficient, both on average and even in the worst-case scenario. The table even shows another one, quick sort, which is usually great, but can fall apart in some situations. The big takeaway here is that not all algorithms are created equal, not by a long shot.
And that brings us to the most crucial point of all. There is no single best algorithm. The most efficient, the best choice, depends entirely on the specific job you need to do. Is the list absolutely massive? Is memory a concern? Is a worst-case meltdown totally unacceptable? That's why computer scientists have a whole toolbox full of different algorithms, so they can pick the right tool for the right job.
So why does any of this sorting stuff matter beyond just organizing a few numbers? Well, because these simple, foundational ideas are the actual building blocks for the unbelievably complex systems that shape our entire world.
I mean, just take that core logic: input, efficient processing, output, and scale it. Scale it way, way up. That fundamental principle is exactly what powers something as advanced as this transformer architecture, which, is the engine behind AIs like ChatGPT. The ideas are the same, they're just applied on a scale that is absolutely mind-boggling.
When you get right down to it, algorithms are so much more than just some abstract computer science concept. They are the invisible instructions that organize our information, that power our apps, and that are actively, right now, building our digital reality. Which leaves us with a final really important question to think about. Who should be writing the code that codes our world?